Hello, we're preparing to take our quiz over lesson 11.6, where we're working with binomial expansion and also binomial probability. I've given you a copy of this practice quiz E, which I'd like you to follow along and fill in as you watch the video. Then you'll work on another version of the practice quiz where you don't get the answers provided. And finally, hopefully that'll prepare you for the actual quiz that we'll take tomorrow. So when you see a problem that asks you to expand each binomial, please note that you'll have to pay attention to the exponent. We use Pascal's triangle to help us expand these. Remember that this first row is 0, so if you're counting down to find the row for a 5 exponent, you're going to count down 6 rows. So 1, 2, 3, 4, 5. So we need this row for our expansion. I'm going to write those values in green. This is how I've done it in class also. So I'm going to space these out. But on this line of the quiz document, go ahead and write these coefficients spaced out. 1, 5, 10, 10, 5, and 1. Then remember that the next thing we deal with is the first term, which for us is just x. We'll start that at a power of 5 and then work it down. X to the 5th, x to the 4th, x cubed, x squared, x to the 1st, and the last term will not have an x variable. Then for the second term, which for us is the letter y, we'll skip the first term and we'll start counting y up. So y to the 1st, y squared, y cubed, y to the 4th, and that last term just has the y to the 5th, but no x factor. And then we also have to pay attention to the operations. Since this is a plus sign here, all of our operations are also plus signs. Okay, so that's the color-coded version. And then what we like to do is just simplify this on the last line. And so our final answer will be x to the 5th plus 5x to the 4th y plus 10x cubed y squared plus 10x squared y cubed plus 5xy to the 4th plus y to the 5th. Just snuck it in there. And let me just put a little highlighter on that. There we go. So this is our expanded form of that binomial if it were multiplied out, distributed with 5 versions of x plus y multiplied together. Just taking a deep breath so you can take this all in. You might want to pause if you need more time to write, but that's the binomial expansion for x plus y to the 5th. The next one on our list is number 2, so let's take a look at that. Number 2, you'll see, is 3x plus y raised to the 3rd power. So we're going to count down to the 3rd row. Remember, this is 0, 1, 2, 3. So we want 1, 3, 3, and 1 for our coefficients. So I space those out, 1, 3, 3, 1. I know those are going to be the coefficients on my terms. Now notice this particular binomial has a more complicated term leading off. It's 3x. So when we count down this term 3x, we're going to cube both the 3 and the x. So 3 cubed is 27 and x cubed is x cubed. And then we'll do 3 squared, which is 9, and x squared. And then we'll do 3 to the 1st, which is 3, and x to the 1st. The last term will not have an x factor. For y, it's very similar to the last example. We don't put y in the first term, we count y up. So y to the 1st, y squared, y cubed. And then, luckily, this one also just has a plus sign for the operations, so these are all plus signs. This time we will have to do some simplifying here. 1 times 27 is 27x cubed, plus 3 times 9 is also 27, and that's x squared y, plus 3 times 3 is 9, and that's xy squared. And then finally 1 times y cubed is just y cubed. And we'll go ahead and highlight that one again. One of the things I want to remind you, which we mentioned in class, is that the sum of the exponents on each of these terms is going to be 3, right? If this exponent here is 3, then all of the exponents that we add up are going to be 3. So here's x cubed, that's 3. X squared and y to the first, that's 3. X and y to the squared, x and y squared, x to the first and y squared. That adds up to 3, and then so is this one. So your variable terms, the exponents on your variable terms, your variable factors in each term will add up to whatever the power is that you're working with. So when you multiply 3x plus y times 3x plus y times 3x plus y, you get 27x cubed plus 27x squared y plus 9xy squared plus y cubed. Again, I'm going to pause for a second just to give you a little time to write this down before we move on to our next item, which is some binomial probability. For the binomial probability problems, I've tried to break it down into smaller chunks so that you can provide answers which will build to the final answer that we're looking for. In this case, on number 3, it says, according to the 2005 census, about 11% of the U.S. population lived in poverty at that time. For this problem, 12 people are chosen at random. So that's what we're dealing with. We're dealing with a sample of 12 people, right? And then here it says, in A through C, we're just going to write the value of the variables. So these are the variables that we use when we're solving these binomial problems. For us, the number of people that we're working with is 12. We just said that. Remember, P is the probability of success, and for us, lived in poverty, I know it sounds weird, but lived in poverty is a success. So we're going to use 11%, but let's put that in as a decimal because that's how we'll have to use it when we do the calculations. If 11% live in poverty, then what is that? 89% do not live in poverty. So that would be 0.89. Okay, let's rewind that. I was going to highlight these bad boys, but I used the wrong color. Let's just do this and this and this. There we go. Okay, so those are the values for N, P, and Q. We haven't identified what to use for R yet because in letters D through H, we're going to have a different value of R for each calculation. So in letter D, our value for R is actually 1. And we're going to perform the calculations for R equals 1. So on the first blank line, we want to actually write out the formula with the values that we're going to use. So as you probably remember, we have to do a combination first. It's NCR. So we're going to do 12C1 because our value of R is 1. Then we're going to multiply by our P probability, which is 0.11, raised to the R power, which we just said was 1. And that means our Q probability, which is our failures, in this case, success means living in poverty, which I know doesn't sound great. In this case, it'll be 12 minus 1, which is 11. So you might want to pause here and take a moment to actually type this in on your calculator. But you can type this all out. Our calculators that we provide have these capabilities. And when you do that, let's round off to 4 decimal places. I believe you get 0.3663. And what we've calculated there is the probability that there is one of our 12 people living in poverty. Okay, remember, right here we've stated that people living in poverty is our success. Okay, let's keep it rolling here. In the next letter, letter E, we're doing P of 2, so R equals 2. So we're going to do a 12C2. And that means we're going to raise our 0.11 probability, our P. We're going to raise that to the second power. I'm just trying to use this color so you can see how whatever number you write down here on the C is the same one that you write right here. And then for our 0.89, which is our Q probability, we're going to raise that to 12 minus 2, which is 10. Again, might want to pause the video but do this calculation on your calculator. But when I did the calculation, I came up with 0.2490. Now, as you know, it's possible that I may have made a mistake, and if I did, I'm sure you'll let me know about it. That's no problem. Mistakes happen. But I'm going to go with these two values for now. So we've done E and we've done D. We have to do F, G, and H. Let's do those on the next slide. So for letter F, we want to find the probability that 3 people are living in poverty out of our 12 that we've chosen. So we're going to do 12C3. And for our 11% probability, our P, we're going to raise that to the third power. And for our 89%, we're going to raise that to the 12 minus 3 power, which is 9. And I'll stall for a minute in case you want to pause the video. But when I did this calculation, I came up with 0.1026. Again, go ahead and round those off to 4 decimal places. We're actually going to use these calculations for a later part of this handout, so keep those handy and go to 4 decimal places. Now it's kind of like a broken record here. We're doing P4, probability that 4 people are living in poverty out of our 12. So that's about a third of our people that we're wondering what the probability is that they would be living in poverty. So we're going to do a 12C4. We're going to raise that 0.11 to the 4th power. And we're going to raise that 0.89 to the 12 minus 4, which would be 8th power. And when I cranked this out on my calculator, I'll stall here in case you want to pause. My calculation came out to 0.0285. 0.0285. Finally, if we want to find the probability that 5 people of the 12 that we chose were living in poverty, we'd say 12C5. We'd raise the 0.11 to the 5th power, and we'd multiply that by 0.89 raised to the 12 minus 5, which is 7th power. And of course, I've already done this calculation. I'm going to pause in case you want to pause this for a second. When I did this calculation, it was very small, 0.0056. That was the probability that 5 of our people that we'd chosen at random would be living in poverty based on the data that we were given. So we've made these calculations for P1 through P5. In letter I, we actually are asked to use them all to solve a different problem. So let's take a look at that. Letter I says find, there's a little typo. I got a capital I right there. That's funny. I'll put a frown face there just to remind myself to fix that in the document. Find the probability that 1, 2, 3, 4, or 5 people of our 12 chosen at random are living in poverty. Find the probability that 1, 2, 3, 4, or 5 of the 12 people chosen at random are living in poverty. There's 2 typos. Another frown face. Come on, man. Okay, so here's the cool thing. If we just want to find the probability of P, 1 or 2 or 3 or 4 or 5, we just add the probabilities that we've already calculated together. So all we're going to do is take the information that we used above and add them up. So 0.3663 plus, and I want you to write this out on this line, 0.2490 plus 0.1026 plus 0.0285. I'm going to run out of space. 0.0056. We're just adding up the 5 probabilities. Remember, when it's an OR, we add the probabilities. So we already made the calculations. We don't need to redo them. We're just going to add up these values. And I added that up, and my probability came out to be 0.7520. And so basically, what we're saying is that approximately 75%, there's a 75% chance that 1, 2, 3, 4, or 5 of our 12 people will be living in poverty. So a pretty high chance that we'll hit that. Not a very high chance that there will be 5, but there's a pretty high chance that there will be 1, 2, or 3. And that's when you add those numbers up, this is taking up a lot of that calculation. These guys aren't contributing as much. Okay, so that was number 3. Number 3 was long. Let's see if we can use what we learned in number 3 to solve number 4, and we'll be done with this thing. In number 4, we're told that 4 out of 7 movies have a happy ending. Well, that's good to know. Let's put a smiley face on there. 4 out of 7 have a happy ending. My wife likes happy endings in her movies. 4 out of 7. So that's our success probability. What's the approximate probability that at least 9 of the 10 movies released have a happy ending? At least 9 of 10 movies have a happy ending. Okay. So this is an at least, meaning we have to include both the probability for 9 and the probability for 10. Oh, my phone just buzzed. I'm not editing that out of the movie because I'm too lazy. Okay, so our population is 10. We've got 10 movies. We have 2 values of R because we're going to compute the probability for 9 of the 10 movies and for 10 of the 10 movies because it says at least 9. Our probability of success is 4/7. That means the probability of failure is 3/7. Remember, the way we do that is 1 minus 4/7 to get 3/7. So we've got the setup for our problem. We've got our 10 for our sample. First, we're going to do the probability for 9, then we'll do the probability for 10. The probability of success is 4/7, and the probability of failure is 3/7. Okay. So basically, we're asked to find P9 plus P10. That's the same as finding the probability that at least 9 of the 10 movies will have happy endings. So for the calculations, we're going to have to do them both. And you can do them all on one line on your calculator if you're careful. We're going to do 10C9. Oops, I've been doing that in green. Let's just put it in green there. 10C9 times the probability of success raised to the 9th power times the probability of failure raised to the 1st power. Now, since you're raising it to the 1st power because it's 10 minus 9, you don't need to write that little 1. It'll save you some typing on your calculator. The other combination is going to be a 10C10. And we're going to multiply that by our success probability raised to the 10th power. And then we would be writing 3/7 raised to the 0 power. Since it's raised to the 0 power, that's just 1. I'm not going to write that down because it's a waste of time typing it on the calculator. And of course, I've already made this calculation. The probability that at least 9 of the 10 movies released have happy endings is 0.0316, or about 3% chance that 9 or 10 of the movies have a happy ending. Okay, so let me just highlight that and we'll wrap this up. So these 4 problems are very, very similar to your quiz that you'll be taking. This is our practice version. Hopefully you've copied down everything that we've done so that you have this as a reference when you work on the other practice version in class today. Once we know that we've practiced a little bit, we'll throw an actual quiz at you and see how you do. Really just want to make sure we know how to select these numbers and push these buttons, and also practice picking out the coefficients from the Pascal's triangle. Good luck on this, and we'll talk soon. See ya.